The main idea of today's lesson is trying to figure out which formula to use with which type of real-world situation. So the formulas that we learned were the percent proportion, which is this one, that is over of equals percent over 100. We learned how to use that as a percent equation, part equals percent times whole. Another formula we used was a percent of change. So when you're looking for that percent of change, like did it increase by 50% or what percent did it increase by or decrease by, use that formula. Another one we looked at was our discount markup. So this is if you are given a sale price and you have an original amount or you want to find the original amount or you want to find the sale price, use that formula. And the last formula we were given is the interest formula. The interest equals principal times rate times time. So the biggest piece of doing this is saying, all right, let me read through the problem and then let me figure out what is this problem asking me. So when you find out what is this problem asking me, you ask yourself, which one of these 5 equations or these 5 formulas is going to work for me? And honestly, if you prefer to use proportions over the proportions over the percent equation, you actually only have 4 different formulas to worry about because these 2 formulas at the top there, they're interchangeable. They mean the same thing. They all talk about that part to whole relationship. So when you're doing these, the first thing you want to do is you want to read that problem and see what is it asking me to find and which formula does that fit with. It says at a restaurant, $1.65 a tax was added to a $27.50 food bill. What is the percent of tax? So we're looking for a percent of something. We're looking for that percent of tax, percent of something. This one is going to be your part to whole. What you need to do then is set it up into the formula. So you have to decide, well, $1.65 versus $27.50. $1.65 is your part of it. That's part of the entire food bill. So $1.65 equals what percent? That's what I'm looking for. $27.50. At this point, you know how to solve this. So I'm going to just give you the percentage that it's going to be. You're going to get 0.06, which then turns into 6%. So the biggest piece here is deciding, well, what is the question asking me to find? So which formula makes the most sense? In the next one, it says, Dr. Austin's car holds 30 gallons of gas. On a trip to the shore, he used 85% of the tank. How much gas is left in his tank after taking the trip? So we're looking for how much gas is left in the tank. Are you looking for a percent of change? Are you looking for an original amount or a discount? Are you looking for interest, principal, rate, time, or are you looking for a part and or whole? So for this one, you are looking for part and whole again. You know that his car holds 30 gallons. That's the whole amount. It holds that 30 gallons. You know that he used 85% of the gas. So that's your percentage. It says how much gas is left in his tank. This one's a little bit of a trick. So that's part, okay? So when we figure this out, we'll get X is going to equal 25.5. Now, you have to understand that 25.5, if you're saying that the tank holds 30 gallons, he used 85% of that. So out of this 30 gallons, he used 85%. I want to know how much is left, so I want to know this part. So even though we just figured out 25.5, well, that's the 85%. So you can take that value and subtract it from 30, and that's going to give you the 4.5. Or you can think of it as being 85% of the tank is full, 15% is remaining. So that's your part that you're looking for. So what is 15% of 30? So you can solve it like that. For the next one, it says 12% of the students were absent from school yesterday. If there are 1,600 students at Lionville Middle School, how many students attended school yesterday? Think about what the values mean. 12% of your students. Okay, that talks nothing about interest, rate, time, any of that. So it's definitely not that one. We're not talking about an original amount of something or an increase of percentage, and I'm given the percent, so I don't need to find a percentage change. So once again, this is your part to whole. So 12% of the students were absent. If there's 1,600, you just have to determine what do those two values mean. So you have X is your part equals 12% of 1,600, the whole. You're looking for that part again. So X is equal to 192. And again, 192 represents, like, your part and your percent have to mean the same thing. So 12% means the kids that were absent. So 192 means the kids that were absent. How many students attended school? All right, so that's looking for if I had 1,600 and I knew 192 were absent. That means that there are 1,408 that attended school yesterday. Okay, so it's kind of the same concept as the car, where you're looking for, if you knew 12% were absent, that means 88% were there. So you could have figured out what 88% of 1,600 was and solved it that way. So the most important thing you have to remember is, what is this problem asking me to find? So which formula makes sense? In the next one, population of LMS was 1,425 in 2010. The population is currently 1,653. Find the percent of increase. Right there, you should know exactly which formula to use. It's asking for your percent of increase. Use your percent of change formula. So percent of change equals your amount of change. So how much did it change by? It went 228. It went from 1425 to 1653, so that's 228. Over original amount. Where did it start? Okay, it started at 1425. So you'll find out that your percent of increase is going to be 0.16, okay, which is 16%. So again, read the problem. What's it asking me to find? Which formula makes sense? Pair of shoes that originally cost $35 are on sale for 25% off. What is the sale price? Am I looking for part to whole? Am I looking for interest? Am I looking for a percentage? Or am I looking for a new amount? We're looking for that new amount. So if a pair of shorts originally cost, so there you go, they're originally $35, on sale for 25% off. I know my percentage changed, so I'm not using that formula. What is my sale price? Well, that's my new amount. So my new amount equals, and then it is 25% off, so it's 1 minus 0.25. And I know my original amount is $35. Okay? So when you go to solve this, you're going to get X equals, and you guys know how to solve, so I'm not going to go through all the work, $26.25. So your shorts are on sale for $26.25. After a 40% discount, a pair of shoes costs $33. What was the original price? Again, look through your formulas. Decide which one you're going to use. What is it asking me to find? So after a 40% discount, a pair of shoes cost $33. What's the original? I'm looking for that original price. The one that makes the most sense is your discount markup, because I'm not looking for a percent of change. And the only other formula that talks about an original amount is that discount markup. So in this one, my new price is $33. So 33 equals 1, it's always 1, minus, because it's a 40% discount, so 0.4. And then that's going to be times my original amount, which is what I'm looking for. So all said and done, when you go and solve this, it's going to be X equals $55. So the original, that would be a 5. The original price is $55. Again, what is it asking you to find? So which formula makes the most sense? So we're going to bypass this one. So in this next one, Emily borrowed $500 for 3 years at a simple interest rate of 6%. How much interest will be due at the end of the 3 years? How much will Emily have to repay? Again, am I looking for a percent of change? Am I looking for a part and whole relationship? Am I looking for a sales amount or an increase in a markup in a price? This one uses the words simple interest. If you see those words, use the interest formula. It is the only formula here that we have that's going to work. So if she borrowed $500 for 3 years at a rate of 6%, how much will be due at the end? All right, well, if interest equals your principal, which is 500, because that's the amount she borrowed, times the rate, always in its decimal form, times the time, always in years, you're going to be able to figure out how much interest. So her interest equals $90. And then this question then asks you how much will she have to repay. You can't just borrow money and not repay that $500 back plus the interest. So to figure out exactly how much she has to repay, you take your $500 principal and add your interest to it. So it's going to be $590 that she has to repay. Wes maintained a balance of $250 in his savings account for 8 years. The financial institution paid a simple interest rate of 4%. What was the amount of interest earned? Again, it talks about interest. So you need to use your interest formula. That's the only formula that's going to work. So simple interest. Okay, so you're going to have interest equals your principal, which is $250, times your rate, which is 4%, times your time, which is 8 years. So what's the amount that it earns? Well, his account after 8 years is going to earn $80. Okay. When you're doing these, be sure to read your problems, decide what is this problem asking me to find, and then choose the formula that makes the most sense. If it talks about simple interest, if it literally uses those words, simple interest, like this, simple interest, there's only one formula that you can use, and that's your interest formula. When you are looking for, like a store, in this one, we didn't do this one, but it says a store pays $75 for an aquarium. If the markup is 15%, what is the selling price? Well, that's your discount markup formula right there. You're looking for that selling price. That's that new amount. When you have trying to grab this, there we go. When you have a problem that talks about part of something, like in this problem here, he used 85% of the entire gallon of gas. That's part of the whole. Those are your percent, proportion, and percent equation formulas. So the key is to figure out which formula makes the most sense when you're doing these word problems.